This is what I call classic. This is a classic problem. You want to tell me something?
No, shall I do this?
This is a classic composite. They give us the composite. They give us one of the functions, and we need to get the other one. Okay, that's what's happening here. They give me G composed with F. They give me G. What do you think we want to get?
F.
We want to find an F. Okay, that's what we're going to do here. So we recognize that when we take, for example, G inverse composed with G.
Identity.
This is identity function, right? So if I can introduce G inverse on the left-hand side of this equation, then I could get the identity, which when put together with F, what happens when I compose I with F? I get F, okay? And that would be good, because if I can get F, then I can get F inverse. And if I can get F inverse, then I can answer the problem. Okay, so that's going to be the strategy here. Alright? But remember, if you introduce G inverse on the left side of this equation, you must also introduce G inverse on the other side, on the right side, to keep a balanced equation. Okay? Alright. So the first thing, of course, if you're going to introduce G inverse, we have to know what is G inverse, right? We have G, but we don't have G inverse. So our step number one, get G inverse. Alright? So I take G, function G. G of x is 2x minus 1. Okay? I want G inverse. So I say this. I say, I don't know what it is. I give it a name. I call it P. G inverse of x equals P. Now, we say turn it around. Flip it over. If G inverse of x is P, then what do we know?
X plus 1 divided by 2.
G of P is x. Okay, this is the idea that when you have a function and its inverse, the domain and the range, they interchange. All the x's and the y's switch. Okay? And so now, as you look here, you can say, what is G of P? Well, I look at my G rule. What does G do? G takes input, multiplies by 2, subtracts 1. If I put in x, it's going to give me 2 times x minus 1. If I put in 10, it gives me 2 times 10 minus 1. If I put in p, what does it give me? 2p minus 1. Okay, so this is 2p minus 1. That's equal to x. Now, solve for p. Why do we want to solve for p? P is G inverse. And that's what we want. So solving for p means we are finding G inverse. Solve for p. P is x plus 1 over 2. Okay, we have p, we have G inverse. Okay? Now we come back over here. This would be like our potatoes on the stove, right? Our potatoes are now simmering. We put that little pot aside, and now we come over to this pot. This is a different pot, right? Just let them simmer over there. Let's look at this thing. We said we're going to introduce G inverse to both sides of the equation. So like this, I say G inverse compose G compose F of x. Okay, so I put it in on the left side. Notice it's coming in to the left side of the left side. So I have to put it on the left side of the right side. Now what's this thing? We got to give this a name. What do you want to call this one? Give it a name. In class today we called it N. Okay, Q, N, Q, Z, whatever you want to call it. Just give it a name for the moment. Think of it as some function. I put it here, N. And if I'm going to do G inverse compose coming in from the left, I have to do G inverse compose coming in from the right. On the right side. You see?
Balance.
Yeah, keep it balanced. Now we take the composite notation and turn it into the of notation. You know what I'm talking about? So we write this as, how do you read? G inverse compose N, or G inverse of N of x. You see? Like this. Alright? Now, what is N of x? We just did that. We just named 2x minus 3 N, right? So asking for G inverse of N of x means I'm really asking for G inverse of 2x minus 3. Let's write that. G inverse of 2x minus 3. Alright? And we know how to do this now because we have the G inverse rule. G inverse is P. So we're saying G inverse of x is x plus 1 over 2. What does the g inverse function do? It takes x, your input, it adds 1, divides by 2. That's what this function, this g inverse thing does. Plus 1, then divided by 2. Okay, so if you put in 2x minus 3, what will it do? Plus 1, divided by 2. It's going to take 2x minus 3 plus 1 divided by 2. You see? What's that? 2x minus 2 over 2. If you break that apart, isn't that the same thing as 2x over 2 minus 2 over 2, right? So what's this? X minus 1. Okay, so here we go. X minus 1. Alright? What's happening on the left side? On the left side, you can use associative property. You can group these together. Remember that with composition, it's not commutative. You cannot change the order of these things. That will destroy the answer. You won't get the right answer. But you can group things how you want. So I group these together. What is G inverse composed? G? That's I. And I composed F. We're talking about these things here, right? That's F. Okay, now we're really in business here, okay? Because we have the F function, and we want to find, what is it we want to find? F inverse of 1 minus x. Now you have two choices here. One is go through the same routine. You start with F. I don't know what F inverse is. Call it P, blah, 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 and get the inverse of F. Okay? You can do that. But in class today, I showed you an easier thing to do. To skip a step, really. You can do that, but instead of saying, I don't know what F inverse is, how about I don't know what F inverse of 1 minus x is. Give that a name. Let's take F inverse of 1 minus x. F inverse of 1 minus x. Say, I don't know what it is, give it a name, call it P, turn it around, F of P is 1 minus x. F of P, use the function rule. Side, this is the step we were talking about. Okay, so x minus 1 is what I get when I use x. What do I get when I use P? What do I get? F of x is x minus 1. F of 10 is 10 minus 1. F of a million is a million minus 1. F of P is P minus 1. P minus 1. That's 1 minus x. Solve for P because P is F inverse of 1 minus x. Solve for P. Send that over. P is 2 minus x. P is F inverse of 1 minus x. F inverse of 1 minus x is 2 minus x. That's the answer to the problem. That's what they told us to find, isn't it? They want F inverse of 1 minus x. That's what we have. F inverse of 1 minus x. Okay. There's a lot of stuff going on in that problem.